Okay, we're going to be doing lesson 1.4, which is area and perimeter. So the perimeter of a figure is the distance all the way around the shape, versus the area is the amount of space inside of the shape, all of this space right here. Now we're going to work down here to plot the points and find the perimeter of the shape that's graphed. The formulas that we need are on the back of this page, but I'm going to write them on the screen as well. We need to start by graphing point A, which is at -2, 3. So we're going to go to the right, 1, 2, and up, 1, 2, 3. Okay, there's our point A. Now we're going to plot point B. So we're going to go from the origin to the right, 1, 2, 3, and down, 1, 2, 3. Now point C, we're going to go from the origin to the left, 1, 2, and down, 1, 2, 3. And now we're going to connect those points. And we see that we have a right triangle here. So to find the perimeter of that shape, we're going to literally count the lines from point to point. So from A to C, we're going to go 1, 2, 3, 4, 5, 6 units. And now from C to B is 1, 2, 3, 4, 5 units. The distance from A to B is a diagonal distance. We cannot simply count the diagonal distance. You have to either use the distance formula, or since this is a right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared. Now we need to plug in the values of our two sides that we do know as our A and our B, and we're searching for the length of our C, which is our hypotenuse. So our A is 6 squared, our B is 5 squared, which equals C squared. 6 squared is 36, and 5 squared is 25. And that equals C squared. 36 plus 25 is 61. And now we need to cancel the squared. So to do that, we take the inverse, which is the square root. What we do to one side of the equation, we do to the other, so we're going to take the square root of the other side. The squared and the square root cancel, so we're left with C equals the square root of 61, which is approximately 7.8. So this third side here is 7.8. Now that we have the distances of all three sides, we can count the perimeter. So the perimeter is the distance all the way around. So we can just add the sides. So the first side is 6, the second side is 5, and the third side is 7.8. So altogether, the perimeter equals 18.8. Now on to number 2. We're going to start by plotting the point -1, 1. So we're going to start at the origin, go to the left 1 and up 1 for point J. And then point K, we're going to go from the origin to the right, 1, 2, 3, 4, and then up 1. And then L, from the origin to the right, 1, 2, and then down, 1, 2. And then point M, from the origin to the left, 1, 2, 3, and down, 1, 2. Now we're going to connect those points. And now we're going to find the distance of those sides so that we can find the perimeter. So we're going to start counting from point to point. 1, 2, 3, 4, 5 for JK. And we can see it's the same from M to L. Now to find the distance that's diagonal here, we're going to need to make that the hypotenuse of a right triangle. So we're going to draw a vertical line here that goes from point L up to this horizontal line, or you could do it down from J to the horizontal line. Either way, we've got to make a right triangle where that diagonal distance is the hypotenuse. Okay, now that we have a right triangle, we can use Pythagorean theorem to find that diagonal distance. So this distance of the top part of our triangle is 2 units, and the distance vertically is 3 units. So now we're going to find that diagonal distance, C. Okay, let's plug in the values. Our first side is 2. Our second side is 3, and that equals C squared. 2 squared is 4, and 3 squared is 9, and 9 plus 4 is 13. So 13 equals C squared, but we want to know the value of C, so we've got to cancel that squared. The inverse of squaring something is to take the square root, and what we do to one side, we do to the other. So the squared and the square root cancel, so we're left with C equals the square root of 13, which is approximately 3.6. Now that we have this distance, which is the same distance over here, we can find the perimeter by adding up all the sides. So we have from J to K is 5, from N to L is 5, from K to L is 3.6, and from J to M is 3.6. So when we add all of that up, our perimeter equals 17.2. Now we're going to scroll down a little bit, and we're going to find the area of those same shapes. So for number 3, we're finding the area of this first triangle, ABC. So that's a triangle, and the formula for area of a triangle is area equals base times height divided by 2, or base 1/2 base times height. So let's plug in our values. The base of our triangle is from C to B, this horizontal distance, which is 5. And then our height would be our vertical distance from A to C, which is 6. So 5 times 6 is 30, and then we divide that by 2, and we get area equals 15. Okay, the area of that triangle is 15. Now we're going to go over here to number 4, and we're going to find the area of that parallelogram. So the area of a parallelogram formula is written on the back of your paper, but area equals base times height. So our area, our base here for our formula would be from M to L. So that base is 5. Now the height of our figure is going to be a vertical height, not a diagonal height. So the vertical height that we have here is 3. So area equals 5 times 3, which is 15. Right now we're going to scroll down here, and we're going to find the total area of this combined shape here, number 5. So if we look at this shape, it looks like a weird quadrilateral, but there's a line going through the middle here that cuts that shape into 2 triangles, this top triangle and then this bottom triangle. So we're going to call this top triangle, triangle number 1, and then this bottom triangle is going to be triangle number 2 for our purposes. All right, this top triangle looks to be a right triangle. So we're going to first find the area of figure 1, which is the right triangle. So the area of a triangle is area equals base times height divided by 2. So the base of this triangle is 1, 2, 3, 4, 5, 6 units. And then the height of the triangle is 1, 2, 3, 4, 5 units. So our area is 6 times 5, which is 30, divided by 2, which is 15. So the area of our top triangle, the right triangle, is 15. Now we need to find the area of our second triangle down here. Our second figure is once again a triangle, so we have area equals base times height divided by 2. Our base in this case would be 1, 2, 3, 4, 5, 6 units again, times our height. Well, our height is always going to be vertical. So we've got to find from this base all the way down to the bottom of the triangle. So this line here, which looks to be 1, 2, 3, 4 units long. So we have 6 times 4 on the top, which is 24, divided by 2, and 24 divided by 2 is 12. So our area of our second triangle is 12. Now to find the area of the combined, so the total area is going to be our first area, which is 15, plus the second area, which is 12. So our total area is going to be 27 units. All right, now this is our last one. We're going to be finding the total perimeter of that combined shape here on number 6. So we're going to start off by counting that distance from one side to the other. So we're going to start here and count over 1, 2, 3, 4, 5, 6, 7, 8 units on the top. And now we're going to do this side over here. So we're going to do 1, 2, 3, 4 units. And now this other horizontal side is 1, 2, 3, 4, 5, 6 units. And now we just need to figure out this last side here, but it's a diagonal side. So we've got to make this the hypotenuse of this right triangle that they've drawn here for us. So we're going to find the distance of the top of that small triangle, which is 1, 2 units, and then the vertical distance of that line is 4 units. So if we plug that into Pythagorean theorem, we would have 2 squared plus 4 squared equals c squared for our hypotenuse. 2 squared is 4, and 4 squared is 16. And 4 plus 16 is 20. And now we've got to cancel the square. So we're going to take the square root. And what we do to one side, we do the other. The square and the square root cancel. So c equals the square root of 20, which is approximately 4.5. So this last missing side distance is 4.5. Now to find the perimeter of the whole shape, we're going to add those sides together. So 4 plus 8 plus 6 plus 4.5. And we get 22.5 as our final answer. And those are our notes for 1.4. I look forward to seeing you in class.